The Toyota production system ignited the lean revolution, transforming Toyota into one of the world's most profitable automakers. Their assembly line runs on a strict takt time, a cadence driven by projected demand and factory throughput. As each vehicle rolls forward, components and sub-assemblies are pulled in via Kanban systems. Spot a defect? A team member hits the andon or pulls it to stop the line instantly, fixing issues at the source in real time. In this system, takt equals priority, with pull reinforcing flow. The car is the unit of flow or the flow unit. Everything centers on continuous, efficient movement. Contrast this with construction. The product doesn't move, the process does. It's people, tools, materials traversing the site, not the building itself. So the flow unit becomes the train of trades moving in cadence, equally spaced, moving across building zones, the rails for that train. How do we orchestrate this? Through the Takt Production System, or TPS. In construction, mirroring Toyota's TPS. Let's use traffic as our analogy. When cars bunch up, especially behind a slower one, flow grinds to a halt. Sure, some weave ahead, but the bottleneck eventually slows everyone. The cure? Stop, reset, restore spacing, and recommence at an even speed. That's flow. Equal speed and an equal distance apart, just like in manufacturing. In construction, think of each trade like a car, or an automobile, or a bike, or a bicycle, all of them varying in size, speed, and predictability. To sync them, we link them into a takt train, into wagons, packaged workflows that run in a tight sequence. Once linked, we map that train on a takt plan. Zones down the side, time along the top, trains flowing in line like an assembly timetable. This produces a production line in construction, functioning just like Toyota's. We pull labor, materials, details into each takt wagon. We can halt the line to address issues at their root, just like in TPS. With takt visibility, we gain system control. If the train is elongated, it's crawling too slow. If it's compressed or tall, it's racing and going maybe too fast. If it's fragmented, you've got multiple unsynchronized trains. And unlike CPM schedules, a takt train never stretches or stacks trades. That's why CPM delays are so common. Managing the train means identifying and resolving constraints and roadblocks. Constraint examples are misjudged takt time or packaging, uneven train speeds, resource shortages or missing buffers, poor zone configuration, or things that affect the train of trades or the train tracks. Roadblock examples are weather delays or plan changes, incomplete site prep, permissions, or layout, defects, inspection failures or material shortages, and labor or equipment issues, or things that are in the way of the train of trades. Construction teams tackle these issues in structured meetings. The strategic planning and procurement meeting, where we observe the macro level strategic takt plan and the procurement log to make sure that we have the strategy and materials for the job site. The trade partner weekly tactical, where we finalize the pull plans, look ahead plans, and weekly work plans to create short interval plans that are roadblock free. The afternoon foreman huddle, where we prepare for the next day. Zone control walks, where we compare the look ahead and the weekly work plan to the actual and we manage handoffs. And then the team daily huddle, where we solve problems real time with the project team. Do you want to flow the takt way? Well, first, design the process as a linear production line. 2, run it in takt trains to keep continuous rhythmic flow. And 3, maintain it by adjusting constraints and removing roadblocks. This is the fastest and most predictable path to complete projects. Are you ready to bring TPS to your job site and transform your flow? If so, on we go.